Hey AP Chemistry kids, it's Mrs. Coleman here. Today we're going to talk about the units involved in thermodynamic calculations. Thermodynamics is all about energy, and so far we've learned a lot of different equations and a lot of different units, and they're hard to keep straight. So we're going to work on that a little bit right now. If we take a look at the different measurements that we make in thermodynamics, they have very different units. If we're looking at straight energy, we're going to use the unit joules. As we get into more complicated measurements like enthalpy or entropy or Gibbs free energy, we can see that the units take on a very different shape. So when we do our calculations with our four common equations, it's sometimes really difficult to understand if our unit at the end of our answer should have per mole or not per mole. So let's take a look at a few examples. Let's say we're doing an experiment where we have to do a reaction inside of a calorimeter. In this case, we're going to use the equation enthalpy equals mc delta T. So we take our lab data, let's say we're using 100 milliliters of 1 molar HCl and we're reacting it with 1/2 gram of magnesium. We're going to assume that the HCl has the same specific heat capacity as water, which is 4.18 joules per gram degree Celsius. And we measured our initial temperature at 20 degrees Celsius and our final temperature at 35 degrees Celsius. So we can plug all those values into our equation. We can go ahead and calculate our change in temperature, and then we can go ahead and look at our units. As you notice, the grams cancel because we're dividing by grams, as do the degrees Celsius because we're dividing by degrees Celsius. That leaves us with the unit joules. Now, we can also change joules into kilojoules simply by dividing by 1,000. Okay? And so we can see here that our delta H value is not going to have a per mole unit. But let's say we're calculating delta H using the reactants or the products. And same thing with delta S using the reactants and products. Maybe we're using this to eventually get to our delta G values. So you would first go ahead and look up the different enthalpies of the reactants and products so that we could plug them into our equation. Now, remember, we have to multiply by the coefficients in our balanced equation because enthalpy is an extrinsic property. It depends on how much we have. So when you look here, you'll notice that because we're dividing by moles, the moles cancel. And so when you do the math, the unit on our math is kilojoules only. The same thing applies when we're calculating our delta S values. Our moles cancel because we're dividing by the unit mole. And so when we calculate our delta S value, our unit is joules per Kelvin. Now, AP will accept these units, and according to the equation, these are the correct units. However, a lot of times what you'll see is they're expressed in per mole units anyways. That's because they're assuming that this is the change in enthalpy per mole of this equation, or that this is the change in entropy per 1 mole of the equation. So if we go and put this information back into our Gibbs free energy equation, we can see that the units are going to cancel again. Our kelvins cancel. Our kilojoules and our moles do not cancel because we're not dividing by either of those things. So when we calculate our Gibbs free energy, we're going to get a kilojoules per mole unit on the end. I hope this clears up some of the questions you had about units and thermochemical calculations, and I will see you guys soon. Bye.